previously, we deduced these three expressions here and then used those to arrive at this expression here. So this expression involves three variables, L, theta, and phi. So we need to express this equation in terms of one variable and then we can integrate. We've already done all the physics, and so now all that's left is mathematics. We need to integrate from this point to this point here. So that's integrating from this distance, to this distance. Okay, so notice that L is going to be changing as you move along this arc length here. L is getting bigger and bigger and bigger and bigger, right? And then phi is, whenever this point is here, phi is flat like that, but then phi is getting bigger, bigger until it's maximum there, and then it's getting smaller again. And then, of course, theta goes from 0 to pi, like that. Okay, so these three things are varying. We need to integrate in terms of one variable, so we need to eliminate two of them. And we just need to choose which two we want to eliminate. So let's just go ahead and choose to eliminate theta and phi. We can do so by considering the law of cosines twice. So let's first consider where the major hypotenuse is r, capital R that is. And we obtain this expression, and then we solve for the cosine of phi, and we obtain this expression. Notice that this expression only involves one variable, L, where the rest are constants, lowercase r and cap r. So this is solid, okay? Now, the next law of cosines that we will consider is where lowercase l is the major hypotenuse. And then once we write down this equation, we can take differentials. And so we have 2LDL, and then notice that the differential of this and this are each equal to 0 because these are constants. So the differential of a constant is equal to 0. And then, of course, these constants are multiplied out front of this cosine theta, so they stay out front here. And then the differential of cosine theta is just negative sine theta d theta, like so. The negatives cancel. This 2 cancels with this 2. We're left with this. We solve for d theta, and we get this, LDL over r times cap r times sine theta. Okay, now, we need to take those things and substitute back into this expression here. So we're going to substitute for d theta, and we're going to substitute for cosine phi. Now, this expression was solid outright, but when you look at this expression, you might say, well, that doesn't look like it's going to work too well because it's got L, that's fine, but look, it's got a theta also. But conveniently, it's got sine theta, right? Conveniently, this thing has sine theta in the numerator, and that's sine theta in the denominator, and they'll cancel. So it's just a, fortuitous result. Okay, mathematically that is. So we come to here. And so here I've made the substitutions for d theta. I substituted this guy here, LDL over r cap r sine theta. And then for cosine phi, I substituted that expression for cosine phi to get this. Okay, so then the next step is this one here. And in this step, basically, I've just dropped the parentheses around this one. And then, drop the parentheses around the bottom thing, but the parentheses have to stay on the top thing because those are sums and differences, right? You can't just drop the parentheses of that. Okay, so then now it's a matter of canceling. So let's cancel some things. We see that, let's see here, we have this L is canceling with this L, this 2 canceling with this 2, and then let's see, r squared, no, but this r squared here, cap r squared cancels with this cap r squared, the pi is going away, right? And let's see, I think that's about everything that we can cancel, yep. Okay, next step. Last but not least. So then the force is equal to this expression here. Factor out g, lowercase m, cap m, factor out anything you can that's constant. And then look here, r squared, little r squared, and then you have a 4 and you have r. L squared has to stay because it varies. And then the limits of integration are the final sort of, trick to the whole problem. So notice what factors out here. Gm times cap m divided by r squared 4r. Looking familiar? So we're starting to, this is looking good. Okay, So r minus r to r plus r. Notice that we want to go, we're considering the distances from this point to this point here. That's the beginning integration point. So we want this distance for the lower limit. Well, that's equal to r, the distance to the center, minus cap r, right? Gives this distance here. So we put r minus r. And then we want to go all the way to here. So that's little r plus r. So we go to r plus r, like so. Now this integral in here will end up coming out to be 4r, and it will cancel this 4r, and you're left with g cap m little m divided by r squared. QED, quod erat demonstrandum, which means that which was to be demonstrated. So in Latin, it's the quod erat demonstrandum. Okay, see you next time.